Welcome to Getting Started with Kubernetes and Rancher 2.0. Why are we here? We have a lot to go over and a lot we hope to teach you guys, everybody on the line. Today's objective is really to give you a technical introduction to Kubernetes using Rancher. We're going to keep the slides to a minimum, and we will be starting out with some slides, kind of give you a context, give you some concepts, and then dive right into hands-on demo. Please ask questions. This really is meant to be interactive. There is a great question chat feature in GoToWebinar that we're using, and so please use that. Start asking your questions, and we will try to get to all of them as best as possible. So who's on the line? I am Matthew Shear. I'm a community advocate at Rancher. And doing our technical demo and answering a lot of the questions will be Jan Bruder. Jan, thank you for being here. Really happy to have you.
Hi, everyone.
And so if you guys need to reach us after the training, our Twitter handles are here. We are happy to help. Continue to stay connected, stay plugged in. Rancher has a flourishing community. And this is open source software. So, if you want to contribute on GitHub, if you have more questions, then please reach out. In addition, the recording of this session and the slides and the questions and answers that you all ask will be included in an email that will go out, hopefully in the next 24 hours, definitely by end of the day. Friday. And, just to give a little bit more groundwork before we dive in, we hope you have a basic understanding of Docker for this training. We really will focus on Kubernetes and Rancher. We have a lot of great Docker resources on our blog, in our docs, and of course, Docker themselves have a great bounty of resources too. As well, this is the quick start guide for Rancher 2.0. You can get an instance installed and ready to go to play around while we're going through this training, or afterward. Really easy to navigate to on our website. If you just go to rancher.com and then click the deploy button at the top right, it'll take you right here, and or maybe just like one page before that, and you'll be able to get to it really easily. Another resource for everyone, just so you know, we really like to plug our forums and our Slack channel as well. But forums.rancher.com is a great place to ask more in-depth questions, get continued feedback, and if there's anything that Jan and I aren't able to answer here because we don't know or we run out of time, or maybe it's outside of the scope of this intro training, then this is the place, forums.rancher.com, to go to. So at this point, we're going to start talking about Kubernetes, give you some context around why it's important and why everybody really wants to know about it, understand how to use it. And I'm going to turn the presentation over to my compatriot, Jan. Are you ready, sir, to have the reins?
Yes, sir, I'm ready.
All right. Switching it over.
All right. So you should be able to see my screen now. Is it?
Can see it.
You see it?
Yes, sir. You're looking good.
Great. All right. Okay. So let me take off from here. So this is especially interesting, I guess, for any existing Rancher users that have been using Rancher 1.0 versions. As you know, we have been supporting Kubernetes pretty much from the start, but Kubernetes was just one of several orchestrators that you could use in Rancher. So a lot of existing users ask, so why are you focusing on Kubernetes now? What are the reasons for that? And the main reason is really that it was really hard to provide the level of integration that we wanted to in order to give you a better user experience with all these different orchestrators like Docker Swarm, our own orchestrator Kettle, Kubernetes, and so on. And we also saw a big change in the so to say orchestrator markets last year, where the interest in Kubernetes has grown substantially in that time frame, and a lot of organizations have expressed publicized the use of Kubernetes, and that was mainly due to the scalability and the design pattern that Kubernetes provides. And in addition to that, we also have seen a lot of IT vendors come up with their managed Kubernetes offerings. And if you look at the code base of Kubernetes, you can see that it's now supported by all the big players across. So it's not only just Google managing it. We have Red Hat, Huawei, IBM, and all these other organizations. So that makes it really future-proof with support from all these organizations. If you look at, oh, there's one slide missing here. Okay, I'm gonna come that to a moment. So we've also looked at what are the typical challenges that users were facing when deploying Kubernetes, either just vanilla using their own tools or scripts, or even using Rancher 1.0. So one of the challenges is if you deploy Kubernetes clusters across different environments in heterogeneous environments, how to make sure that you have a consistent configuration of your clusters, because there are all these different tools to install Kubernetes. Some of them, they're specifically tailored for example, AWS or a private cloud. So how do you make sure that you get consistent clusters wherever you deploy them? Another challenge was the management of access control and role-based access control in Kubernetes. So Kubernetes has this really fine-grained, very advanced RBAC system, but at a scale, it proves actually to be quite challenging to manage it, because it's tied to these namespace resources, which makes it hard to manage it at scale and provide consistency across different clusters. Another thing that we were often asked about, how do I make more efficient use of my resources? So in Rancher 1.0, we had this concept called environments, which was basically a set collection of resources or nodes, and one configuration, one user configuration. So you couldn't really share one set of resources across different teams, where you also had isolation between them. So this was also something that we looked into. Can you still hear me?
Yeah, I can hear you.
Okay, great. Just want to make sure that I'm not talking into the oblivion. Yeah. So this was also a question: how can I basically implement multi-tenancy with Kubernetes? And then also all these operational challenges with regards to high availability, security, like implementing organizational policies in the clusters with regards to network security and access to administration and to management of applications. And finally, the monitoring. So even when I have my cluster set up, I really want to make sure that I get the visibility to be able to detect any issues and to troubleshoot and fix them. Another challenge with Kubernetes from an operational standpoint is that the development is moving at a very fast pace, which is of course great on the one hand, because you get all these cool new features. But on the other hand, it means you're gonna iterate a lot over qualifying and rolling out new versions. So if you just look at some of the stats in Kubernetes in GitHub, we had over 50,000 commits in a 12-month period. Kubernetes is actually one of the top 5 projects with regards to the number of developers, contributors, and we see more pull requests and issue comments than any other project on GitHub, which is really pretty amazing. The challenge is that until now there is really no long-term support version with Kubernetes, and when we look at some of the releases over the last past 1.5 years or so, you can see that there's a new minor release every 3 months. And minor is really quoted for a reason, because it means often API changes and so on. So you want to really closely follow that release cycle and upgrade and keep your own environment up to date with those, which can be a challenge too. And finally, usability. So the way Kubernetes does all these, the design of Kubernetes really evolved around these abstractions and separation of concerns. And that makes it powerful, but also at the same time, it proves to be quite a bit steep learning curve for users to interact with Kubernetes. The manifests that you write to configure your workloads are quite different from what you may know from Docker Compose files, for example. So you can really leverage that. Even if you are very good with Docker before, you can really leverage that one-to-one to write Kubernetes configuration files. So this was also some things that users noted. Yeah, so what do you get with Rancher? Basically, we got another levels where we provide a better experience with Kubernetes. So starting off with the user experience, we get your user interface for Kubernetes, both for the operational side, but also for users having to manage workloads on Kubernetes. We also provide the same infrastructure management that we did in Rancher 1.0, where we can provision nodes and install Kubernetes across different infrastructures. And on top of that, we provide management of RBAC policies, network policies, and pod security policies across different clusters. So basically, this is really like central management of all these like global configuration items that you want to then use on the clusters. Yeah, so these are basically the levels. On the bottom, you have the environments that we support in Rancher 2.0. So you can use bare metal, you can use VMs in the cloud, in the public cloud, in the private cloud, and the new thing also is that you can even pull in managed Kubernetes clusters that you have created on GKE or Azure, and you can pull them in and manage them with Rancher centrally. So one example is, for example, why I'd want to do that in the case of, for example, Google. You can't really leverage like your local user directory or Active Directory or whatever you might have to authenticate users in your organization. You can't really use that and connect it to your cluster to the managed cluster in Google. So by way of managing it in Rancher, you get that possibility. And just quickly looking at the application design, that has changed quite a bit. So first off, what you're going to notice here is that we no longer use MySQL database for our state store. So now Rancher is actually running as workloads on our Kubernetes clusters itself. So basically, when you deploy Rancher in a high available configuration, what you're going to do is you create a very small Kubernetes cluster. And we also provide the tools to do that. I'm going to come to that in a minute. And then you install all the Rancher services on it. And we actually use the same etcd key value store that Kubernetes uses to store our own configuration and state in there. And then once you have that, let's say, seed cluster or management cluster, then from then on you create the actual Kubernetes clusters to run workloads. Yep. So going further, let's just do a quick Kubernetes 101 for anyone that is not familiar with Kubernetes. As I said before, Kubernetes does a lot of automation, but the more automation you do, the more complex things become. And other than Docker, where you really only have things like containers and maybe volumes and maybe networks, you have a lot more resources in Kubernetes that you need to learn about. So starting off with the pods. So this is the atomic unit in Kubernetes that you are basically dealing with. A pod is basically a collection of containers. It could be just one container or more. And these containers are always scheduled or deployed to a node together. So they have a common lifespan. And the other special thing about it is that they share some kernel namespaces. For example, they share the network namespace, which means that they can talk to each other on localhost, but also only ever one container in a pod can bind to the same port. Yeah, most of the times you're gonna see just one container in a pod, but there are some deployment patterns where the pods are really handy. For example, if you have an application container and you want to provide some bootstrapping or some configuration that is done outside in a like special configuration container. Yeah, so it's what I call like a sidekick pattern. So in that case, these pods come quite handy. And this is, as I said, the atomic unit you're dealing with. You're not ever managing containers directly. Yeah, I'm just going to skip this. And the next thing is replication controllers or replica sets. So what these are basically, they are the source of truth for the pods, really. And so most of the time, you're not even going to create a pod directly, but instead you're going to define the properties of the pod in a replica set. And then Kubernetes has the service called Controller Manager. And this one basically takes the replica set and then tries to drive the state of the cluster to the state that you defined in the replica set. And then there is even another level of abstraction above it, which is called deployments. And deployments basically provides declarative updates for pods and replica sets. So it's basically like an operator for replica sets, which knows how to perform rolling upgrades and how to scale applications. So if you create a workload, that is actually most of the time recommended to use a deployment instead of directly defining a replica set. And the services is another resource that concerns the networking for your application. So by default, if you deploy a replica set or a pod in your cluster, you don't really have a defined way on how to access it other than using the IP address of the pod directly. What the services give you, depending on the type of service that you deploy, is the most basic type would be a cluster IP service. What this means is basically like an internal load balancer. It gives you an endpoint that you give to any other application that might want to interact with a specific application. So, and it also gives you a DNS name for service discovery. So normally, like if you have, let's say you have a multi-tier application where you have a database and some front end and needs to talk to the database, you would normally give the front end a DNS entry that points to the service of that database. And then the service itself will do round robin load balancing. And if you have multiple instances of the application, it will do round robin between those instances. And there are another service types. The next one is a node port. This is basically binding a port on the node to a port on the container. And the specific about this is that other in what you maybe know from Docker, where you can also bind a node port to a container. In this case, the port will actually be opened on any node in the cluster. So not just the host where the pod is running on. you can go to any node IP of the cluster on that given port, and the request will be forwarded to the pod, even if the pod is running on a different node. And finally, we have the type load balancer, and this is really referring to an infrastructure load balancer, so something that exists outside of the cluster in your environment. One example would be an elastic load balancer in AWS. And what this does is that it actually dynamically provisions the external load balancer, for example, the ELB in AWS, and configures it with the backend, with the IPs of the backends for the load balancer to forward requests to. And then going on, there are also config maps. So basically, what they allow you is to decouple the configuration from the actual pod spec. So previously, like with Docker, often what you would do is to provide configuration to your container is use environment variables and provide the values of these environment variables in the Docker compose file. So these config maps, you get decoupling. So basically, it's a kind of like a key value store where you can add arbitrary values for configuration, and then you can reference these config maps in your replica set or in your deployment, and you can either then provide it to the container as environment variables, or even as files in a temporary file system in the container that will be mounted to the container. And then finally, we have so-called ingresses. So ingress is basically any entity outside of your cluster that knows how to route requests. So normally it would be a reverse proxy load balancer. It could be even an IP router, and basically an ingress provides a very dynamic way and a lot of configurations to define how traffic is reaching your application. Yeah, so the most basic example would be a reverse proxy like Nginx, and which gives you then layer 7 capabilities for routing your traffic based on the host name and path. Yeah, so that's it for the short Kubernetes introduction. Now we're gonna walk you through setting up Rancher 2.0. So as Matthew already pointed out, we have a pretty good quick start guide on our website. And for the purpose of this session, you can just follow along, just follow me talking, or if you have 2 VMs that you can get access to quickly, you can actually just trying to replicate the quick start guide. So with Rancher, there are multiple ways to deploy it. Its most simple form is to deploy our single node Rancher server, which is basically a container that contains all the components of a Rancher deployment. And then for production usage, there you would use the HA deployment, which is a multi-node deployment and requires you to bootstrap a Kubernetes cluster. And for that purpose, we have our own Kubernetes installer. It's called RKE. The way you use it is we have a single declarative file where you define the properties of the cluster, and then you have this user space utility RKE, which creates the cluster. So this does not provision nodes. So this requires you to provision the VMs beforehand, and then just configuring it with the address of all the nodes. Yeah, so this is for the advanced production deployment. We're not gonna go in depth now. So for this purpose, we're gonna use the one node install, which is the same as in Rancher 1.0, basically a container. Yeah, so starting off, here are the requirements. With regards to the operating system, memory and the support Docker versions. So make sure you have one of these Docker versions. There's actually a nice way to make sure you install a specific Docker version. We have these install scripts that allow you to basically to get a particular Docker version. So this is the way I installed it in my VM. It's just curling the script and piping it through SH. Yeah, so let's check now if I have Docker installed. So yeah, it's running. Okay. So now we're gonna execute this command to run the Rancher server container. So this is just the most basic form of this command. There are some advanced flags that you can provide. For example, to mount the data folder to a host or to a named volume, or even to use Let's Encrypt certificates. So in this basic form, basically you will create a self-signed certificate. But again, you can mount your own certificate or use Let's Encrypt to dynamically create one once the container starts. So we're just gonna pass this in, and we're gonna open port 80 and 443. Port 80 is just gonna be a redirect to enforce HTTPS. And yeah, so this will pull the image and start the container. And yeah, so this is going to take 1 or 2 minutes to start up. And then once that is started up, you can access the GUI at port 80 on the IP address. So while it's starting up, maybe there are already some questions, Matthew?
Yeah, let's see. Luke asks, we installed an RKE Kubernetes cluster. Is it possible to upgrade Kubernetes to a new version?
Yeah, absolutely. Yeah, absolutely possible. So basically, if you look at the full example here, let's see. Yeah, basically you have to update the system images, the Kubernetes components here. So these are the Kubernetes API components. And you can see this is already, I think, the latest version that we currently support in Rancher. So basically you have to update the versions of these images and then run RKE up. Yeah.
Awesome.
Yeah.
Okay. Nicolas asks about container orchestration. He says Swarm isn't supported in Rancher 2.0. Is that right?
Yeah, that is correct. So that's what I was hinting before. In Rancher 1. You had the choice between different orchestrators, but because we wanted to improve the level of integration, we really just want to focus on one of them. And with all the drive that Kubernetes has, we decided to focus on Kubernetes. So Docker Swarm is not supported.
Cool. And then one more. I'm sure I'm going to butcher your name. Fricky says, is there a guide on how to deploy the Kubernetes dashboard in Rancher 2.0 in the similar to how there was one available in Rancher 1.6?
Okay, yeah, you should still be able to do that. I don't know if it is available. There might be even a Helm chart, and if that is the case, you could deploy it using the catalog that we still have in Rancher 2. But we can have a look at this in a minute. Yeah.
Excellent. All right. There's a couple more, but I think.
Yeah. All right. So let's begin. So okay. So the server instance has fully started up, and now by default we restrict access to the install. So you have to set your initial admin password here. And then you want to set the server URL. So because I'm not behind some load balancer or anything like that, I'll just leave it to the one that he automatically determined. In some cases, you want to set this to another IP address if you're behind a load balancer, for example. Yeah, and then we get to this global view. So you can see we don't have any clusters yet. And let's just quickly go through some of the options that we see here. So the first thing probably that you want to do if you don't want to use like local authentication is to set up authentication with some external user directory. And in this version, we support Active Directory in GitHub. In the upcoming versions, we're going to add support for OpenLDAP and SAML. So yeah, this will grow. Yeah, so this is where you can set this up. And then the next thing that you define at a global level are the role-based access control roles. So that way, basically, Rancher becomes a single source of truth for the roles that you use to manage access to your clusters. And then when you create new clusters, you can always reference these roles. And there are some, as I said, the RBAC system in Kubernetes is quite low level. So these are just some of the pre-configured roles that we have, like for a cluster owner, a cluster member. Then on the project level, you can have roles for users that just manage storage, just manage volumes, or just like a read-only role for specific user groups. These are some of the predefined ones, and then you can really get to the nitty-gritty and create your own roles here. Nice thing is that these work in an additive way, so you can inherit from an existing role and then grant additional privileges on top of that. So basically, for any resource in the Kubernetes API system, you can define the CRUD privileges for it. You can see there are lots of them. So again, just here, you're gonna spend some time figuring out the best way to create roles that you need in your organization. And yeah, so then the other thing that we define globally is the pod security policies. So these basically define restrictions with regards to the privileges of containers that run in your clusters. So things like mounting a host directory, for example, or additional capabilities for kernel syscalls, like for mounting stuff and things like that. So these you can also define globally. Yeah, or another example would be like passing in through system devices like a GPU card if you do any kind of workloads that need the GPU for acceleration or something like that. So yeah, so these basically define the boundaries of the privilege that pods can be deployed in the cluster. So these would be like capabilities, like kernel capabilities, the type of volumes that can be used. So this is really all about security. And again, nice thing is that you can define them once on the global level and then apply them to any of the clusters so that you get consistency. Yeah, moving on, settings, gonna skip this at the moment. So these are your basically local users, because right now I don't have like a external user directory connected to it. So I can just create a normal user and can make him an administrator of the cluster or just a standard user. If I make him a standard user, he will I will need to authorize him explicitly in any of the projects or clusters that they create. Yeah, so moving on to catalogs. So catalogs is pretty well known if for people using Rancher 1. It's a very appreciated feature for our users, and we continue to support that. A difference, of course, is because we are integrating with Kubernetes now, is that we use the Helm chart format for catalogs, so no Docker Compose files anymore. And we actually extended the Helm chart format in a way that you can still provide custom runtime configurations in the user interface. So basically, when you deploy a Helm chart, the users are able to fill out a form with any of the custom configurations. That I'm going to show that in a minute. Basically, here you can define what kind of catalogs should be available. If you want the Helm stable is basically the official Kubernetes catalog, and then you can create custom catalogs for your organization, where you just put in any kind of stacks that your organization wants to regularly deploy. Next up is node drivers. So node drivers are the services that implement provisioning of nodes out, from within Rancher. So these allow you to provision VMs in all these public and private clouds. And there's a set of them active by default. Some of them you need to enable specifically. And there's also a way to use custom node drivers. So these node drivers, they're all based on the Docker Machine project. And there are a lot of plugins for this one. So you can add more node drivers for any cloud that is not in this list here. And let's see if anything here. Okay, so here, API keys. So this is where you create API keys for either implementing your own Rancher API client or using the command line tools that we have, like the Rancher CLI tool. So this is where you set up, where you create your API keys. Yeah, so that's basically the global level, and then we can go into creating a cluster. So again, here the add cluster. Some of these options will be familiar to you if you use Rancher 1.0, like the EC2, Azure, and so on. The first two are the new ones. So this is basically creating a managed cluster in one of these clouds. So this will create a managed Kubernetes cluster there, and then make it manageable in Rancher. And with these ones, we will provision. What happens is that we will provision VMs and configure like VPC and stuff like that. And then we will use, actually under the hood, we will use RKE to install the Kubernetes cluster on top of these nodes. And then we have also import. So you might ask yourself, what is import? Import is basically any kind of Kubernetes cluster that you already have deployed anywhere. And the way you import it is basically providing the API endpoint to that Kubernetes cluster and giving the required access privileges. And then what we're going to do now is we're going to use custom. So this is really for things like using bare metal, or if you provision your VMs outside, like in a custom, your own cloud setup, and you don't want to use Rancher to provision nodes, and you already have your kind of provisioning framework to create new VMs, then this is the one that you're going to use. So this basically expects existing VMs that have a supported operating system and a supported Docker version on it. And then you can set up your Kubernetes options. You can choose the version of Kubernetes that you want to deploy, the network provider that you want to use. So right now we support 3. With this last one is actually a combination of Flannel and Calico. Yeah, you can select the pod security policies that should be applied to this cluster, and a number of other things. Going back, while I think about it, I just want to go back quickly here, because I want to show you some of the nice things when you provision out of Rancher. You have a lot of control over basically the properties of your cluster with regards to what kind of VMs do you use for the management plane, what kind of VMs do you use for etcd data plan, and what kind of machines to worker. And this all works through what we call node templates. So basically, a node template is what defines the properties of the VM that is going to be provisioned, like the number of vCPUs, memory, and so on. So this really gives you a lot of control over your cluster. You don't have to use all the same VMs for both the workers and then the management and data plane. So we can create a new node template pretty easily, given that we have credentials. Yeah, so basically this is where you set up the node template once. And this also plays in the whole question of reproducibility. As I said, these templates, you can define them once, and then every time you create a cluster, you can just refer to a template instead of trying to replicate the settings that you used for your other templates. And yeah, and then you can create like different node pools. And this is just like, in case you wonder, basically, why you have these etcd control and worker boxes. So basically, this is what a Kubernetes cluster consists of. So a Kubernetes cluster needs to run the etcd data store for the state. It needs to run control plane services. So this would be something like the Kubernetes API server, schedulers, control managers, and stuff like that. And then worker basically refers to nodes that execute your actual application workloads. So in the most simple form, you could put all on one box. This is nice for a small dev or sandbox environment. And for production environment, there are also different possibilities. So if it's depending on the scale of the cluster, you can put the etcd and the control plane actually on the same set of nodes, but scale this up to 3. That way you both get high availability for the etcd and for the API servers. And then you can choose another set of nodes just for workers, for example. Okay, so this was just a quick excursion for the provisioning. So as I said, we're gonna use the custom one. We're gonna use all the default settings here. And then going on, what happens is we get a Docker command, and this runs the agent that then registers this VM or this node or bare metal, whatever it is in the cluster. And okay, so starting off, I first have to create a node that runs etcd and control services. So copy this to the clipboard, and then I have here one with Docker installed. Okay. So it's going to pull the agent down. And then we should see it coming up pretty quickly. Yeah, so one new node has registered. So now I want to create another node that just for running my application workloads. So I give it a different role of worker and register that as well. So what happens now is once these nodes have registered, Rancher is going to install the Kubernetes cluster on it. So basically that's what happens now. So I think we can maybe do another pause while this is happening.
Yeah, let's see. Couple questions, Jan, can you hear me okay?
I hear you.
Okay, great. Ryan asks, when you deploy an EC2 cluster, do you need to configure cluster.yaml, or is it configured automatically for you? Jan?
Yeah. So I'm not quite sure if I understand the question. So if he refers to like RKE, so RKE is an install that can be used outside of Rancher just to manage Kubernetes clusters. So it allows you to to deploy the clusters, manage them, upgrade them, snapshot the etcd data and stuff like that. And normally, when our users deploy a production grade Rancher 2, which runs on a Kubernetes cluster, we normally use RKE to do that. And then in Rancher itself, like now that it's provisioning our cluster, it actually uses RKE as a library under the hood, so you don't need to define cluster. But maybe I'm not sure exactly about this question, but right now you cannot import like a full cluster YAML when you create a cluster in Rancher, but we're going to add support for that, basically allowing you to export and import the cluster YAML that was used for a specific cluster. Okay. I hope that answers it.
Yeah, and Ryan, if you didn't get your question answered, maybe ask it a different way or come back to it. Okay, the next one is from Jay. He says, this is actually a 1.6 question, so we'll see if you can answer it, Jan. It says, I am using a cattle cluster in Rancher 1.6. If I spin up a new container, I'll not be able to execute shell, either from the GUI or from CLI. The shell appears for less than a second and disappears.
Okay, so this looks like a 1.6 question.
It is, so yeah. That's
well, usually if there's an issue with the shell not showing up, it means that because it uses a WebSocket connection to pipe the shell from the container back to your management console. So that usually means there's some kind of networking issue. So I would go to that node that is affected and try to troubleshoot the agent there.
Cool. And Jay, maybe this is also a good question to put in the forums, because there's a lot of 1.6 users there who might be able to help. Next one is from Christian. He asks, can we use CentOS 7.5 when available?
Well, I'm not sure about that specific version, but usually we support all the Red Hat derivatives, like CentOS, Red Hat Enterprise Linux. I'm not sure about that specific version 7.5 though, but please go ahead and post it in the Rancher user Slack, and you will get an answer there.
Cool. Awesome. That's it for now. So you keep going.
All right, cool. So I just realized I didn't give a name to my cluster, but yeah, anyways. So the cluster is now active. Let's go to the cluster level to see what we got there. So we get a nice dashboard, gives us a quick view on the resource utilization and the status of the components. So this is basically all the combined CPUs, memory, and pods. Why is this 220? That's just because in Kubernetes there's a limit of around 100 pods that you can deploy per node. The first thing that you're going to notice is that you can now create a kubeconfig file in order to use kubectl to access that cluster. So it gives you this file. You can copy it and then store it on your laptop, or you can also use like kubectl here, and yeah, just use it in that console. Okay, so this is just to show that if you wanna use kubectl to interact with your cluster, that's the way you do it. Yeah, going on. So this is the nodes overview. We have two nodes here, and they have the roles that we defined. Let's see what else we have here. Oh, okay, so this is stuff that you're gonna want to configure on the cluster level. So first of all is the logging side. This gives you this makes it very easy for you to ship the logs of all the cluster level services, like basically the Kubernetes services, to a log aggregator outside. So, for example, if you have a syslog endpoint somewhere, or you have Splunk or Elasticsearch, you just basically configure the target, and from that moment on, all the cluster logs will be sent there. So that's pretty cool, neat. And the next thing is that we have monitoring enabled by default, and also alerting. So on the cluster level, this is basically monitoring the cluster health itself. So like the data store, etcd, all the different services like the control manager, scheduler, and also the nodes. Like, for example, you want to be alerted if the disk usage is going above a threshold, or CPU or mem usage. So some of them are active by default, and you can create custom alerts for services or for nodes, right? And then define your thresholds and basically the conditions that must be met before sending an alert. And in order to send alerts, you also set up a notifier here. Basically, this is like a notification sync going to Slack, email, PagerDuty, webhook. So this is the cluster level, and this is also where you enable pipeline support, which I'm going to show you in a minute. Basically, you associate your cluster with a GitHub organization or a GitHub account, and then that way in the projects you can set up pipelines for a specific project repository there. And then on the members side, you can define the members on a cluster level, and then again you can do that also on the project level. So these basically are members that have access to the whole cluster. And then as we go over to the project namespace, you will understand why there's another level here. So basically, projects are our way to make it easier to basically have a multi-tenant clusters that you want to share between different projects or teams, where each project is isolated from each other, both on the access level, like on the management level in the API, but also on the networking level of your workloads. Yeah, so that way you can really share a cluster with different teams, and they cannot interfere with each other's workloads. And the way we do that is under the hood we actually leverage the namespacing, but what we do is we just manage it in a smart way that you don't need to bother with it. But it also makes sure that that like the normal workflows that you use for Kubernetes, they don't break. So basically, a project is basically a collection of namespaces that have a common set of access policies. And by default, the project also use network policies to isolate the applications running the project from one another. Because if you have like application A from one team, application B from another team running on the same node, by default, they would be, of course, able to talk to each other. So we are prohibiting that using network policies. Yeah, so this is the cluster level, and by default you get one default project, and here you can create more projects. Like for example, you can create one for team B, use a different pod security policy, and then add your members. So here we would add any members that we define locally. And if you would have set up integration with GitHub or Active Directory, you can just choose users or groups in Active Directory to add to the project. Yeah, so going to the default project, this is what we get here. Again, as I said, you can change the membership of the project. You can add namespaces to the project. So this is a way basically to organize a project a little bit more. by adding additional namespaces for different components or for different application stacks. And then you can see that this resource menu kind of mirrors a little bit what we saw on the cluster side. And that is because here on the project level, we can actually define the logging for our workloads. So other than on the cluster level where we would only forward logs for Kubernetes components or on the cluster level, this actually allows us to set a target for our applications, for our containers that are running here. And the same is true for the monitoring and alerting. So this here, we are not monitoring cluster level stuff, but here we're gonna set up actually alerts for specific workloads. So we can set up an alert, for example, for some kind of backend application or like a web server, Nginx, whatever we have, we can set up notifications for that one. And then in addition to that, we have all these, we have config maps and secrets. So basically, we talked about this before. This is basically a key value store for application configuration. And the same is true for the secrets. And then we can also add certificates here. And these certificates, the purpose of these certificates is to use them in an ingress to terminate SSL directly in the cluster. If you don't want to do it on an external load balancer, you can do it here. And then also registries. So this is all known from Rancher 1. This is when you have like an on-prem Docker registry, or you use like something like Quero or Docker Hub with non-public images. This is where you set up credentials for that, so that you can use these images in your workloads. And let's just go to workloads pretty quick. So let's just launch a very simple workload. Let's just call it hello world. And I think I have somewhere, let's just use the Nginx image. Yeah, so let's look at some of the things that we can configure here. So first of all, we have the scale. So this defines how many instances of a pod I want to run initially. And then we have also more options for different kind of scheduling. So the next one would be run one pod on each node. So this is what is called a daemon set. And the nice properties of a daemon set is that that they basically the scale of the pods scales with your nodes. So whenever you add a new node to environment, it will automatically deploy one pod instance of that workload to that node. So this is interesting for things like monitoring agents that you want to run on each node all the time. And then we have stateful set. So stateful set is a bit of special deployment, which gives you some guarantees with regards to unique host names and making sure that each instance of the deployment is always bound to specific persistent volume, for example. So this is really useful for deploying clustered application, like for example Cassandra, where you need some more padding of the containers. So you always want to make sure that the same Cassandra node has always the same volume attached to it. Yeah, so these are stateful sets, and then you can also create run them on a cron schedule and create a job and so on. So then down here you have all like the advanced configurations, like adding environment variables. You can set up custom scheduling like affinity rules. You can specify health checks for your application. Like for example, you have if you have a web application, you can define the port and here you can find the path and the port to check for health. Like for example, you might have an endpoint like that in your application. So this gives the orchestrator then an idea on the actual health of your pod, other than just knowing that the pod is running, is actually like health of the application itself. So for example, the pod might be running, but your application might not be able to connect to some other backend. So this is where you can set up these health checks. And then you can also add volumes. Yeah, so you have different possibilities here to use no volumes on the host, use existing volume claims that already have been created, or create a new persistent volume dynamically. We're going to come to that in a minute as well. And then you can also define the scaling upgrade policy. This is when you upgrade the service, it defines some rules, like the order in which the pods are upgraded in a rolling fashion, and the batch size and things like that. Yeah, and then also some important thing that we just skipped. How do I actually publish my application? So this one is listing in port 80. So the most basic one really that you can do is the node port. The host port would be similar to the behavior from Docker that you know from Docker. So this would just open a port on the node where that specific pod is running. And the cluster IP gives you like an internal endpoint to reach your application. So this is for like multi-tiered application stacks, just for internal communications. And the layer 4 load balancer is the external load balancer, like ELB on AWS that I mentioned before. And usually the node ports are limited to a specific range in Kubernetes. So by default, it's something like 30,000 to 32,000. And that also means that having a node port alone is not really usable on its own if you want to publish an application to users, to end users, because it will not allow you to publish the application port 80. So this usually is something that you use in combination with an external load balancer, and then just let Kubernetes manage the port. So just let it at random, so that Kubernetes assigns support for the application. Yeah, so let's just health check port. Didn't really want to configure a health check. Okay, so let's just deploy this one here. And we can also, now that it's running, I can also switch quickly to the CLI. So as I said before, we don't hide the Kubernetes, like the vanilla Kubernetes API. So you can interact with the deployment just using the kubectl, which is the normal way to interact with Kubernetes on the CLI. And yeah, you can query all resources with that. Probably have to do all name spaces. Yeah, so this is a full basically export, because I'm an admin, so I have access to all the namespaces, and we can see, like, if we just get the namespace default. Oh, okay, so I'm actually talking to a different cluster. All right, okay. Yeah, let's switch over to that one that I have configured. So, okay, so let's just replicate this here. And use a port mapping for the node port. And this container is running on port 80. And just launch it. And now when I query the default namespace, I should see my deployment being created. So the UI, if you use the UI, this always creates a deployment in Kubernetes terms. And you can see that it has assigned a random port on the node. And when we connect to that port, we get the container. So as I said before, this is not really useful to publishing application to end users. So for that purposes, just remove that. We're actually going to use an ingress load balancer. So let's create this again, Nginx, and we don't do any port mapping right now. Just deploy the application. Object is being okay. And then we go to the load balancer tab, and this allows you to add an ingress. And I said before, an ingress is a way to route traffic to your application. And in this case, it's a layer 7 ingress because under the hood it's an Nginx reverse proxy. So now we add a new, basically we call it just load balancer, and now we can define the layer 7 rules for this one. So I'm just gonna use this generated host name here. You can also set your own host name. So a typical pattern would be that you have a load balancer in your infrastructure that you may be also using. It could just be like a layer 4 load balancer or some load balancer that you use to terminate SSL, and then forward the requests, all the requests to this ingress, and then the ingress does all the layer 7 routing stuff. So here you can set your own DNS name. Yeah, you can also specify a path as an additional rule, and we use the target of the workload that we just created, and we know it's listening on port 80. And now we could also do SSL termination here. So if you would import certificates, you could use them here. Yeah, so this is going to take a couple of seconds for it to provision the DNS name. And we can, while that is going on, we can switch on to service discovery. So this is basically service discovery, DNS service discovery. So first of all, this lists the DNS entries that are created for all the workloads in your cluster. But it also allows you to create custom, basically DNS records that any pod in your cluster will be able to resolve. So it could be like an external service that some application in your cluster needs to reach under a DNS name, or a CNAME. So there are different ways to create custom, basically DNS entries in the internal DNS server. And going back to Lopez, you can see that we now have a fully qualified DNS name for this workload. And when we click this, we have our port 80 endpoint here that forwards to our pod. Yeah, so this is the load balancing side. And then let's have a quick look at volumes, because this is always very interesting for people. So what happens if I have an application that needs to have a persistent storage to store its state? So in the Kubernetes world, this is called a persistent volume claim. And persistent volume claim is really something that you can either define these volumes explicitly and then attach them to a workload, but most of the times what scales much better is if you use dynamic provisioning of volumes using so-called storage classes. And a storage class is basically a provider that knows how to create a volume using some underlying storage like block storage, like a block device, or an NFS export. So basically it knows how to create a volume there. And then this storage class or this provider takes care of attaching that that volume to the pod or to the host where the pod is running on. So it has all these domain expert knowledge how to do that. For example, on AWS, you could have a storage class for EBS block storage, and this storage provider then makes sure that the EBS volume is attached to the node where the pod is running. Yeah, so you see already, this pretty much depends on your environment where you're running. So if you're running on the AWS, you would leverage the EBS disk provisioner, and in other environments, you would use different ones, like in Google, persistent disk. Or even you might have some of these commercial storage solutions like Portworx or Scale.io, and or there's there's even another nice project I just want to point out quickly. It's called Rook, and Rook is really a pretty cool project, open source project. What they're trying to do is use Ceph for hyperconverged storage in a cluster. So basically, it allows you to use the local disk that is attached to your cluster nodes to create a sort of hyperconverged storage. And then for Rook, there would be also you would also have a storage class for that. Yeah, so this is a storage class, and as an example, because I'm here in DigitalOcean. I don't have any like block storage in DigitalOcean right now. So as a quick example, we can go back to our cluster and redeploy an NFS server in the cluster. So this is our catalog, by the way. Click on launch, and you can see these available charts. And this is actually also a good example to see how we enhanced the Helm charts, because they allow you to basically create these dynamic forms so that the users can configure the catalog on deployment. So I think I'm gonna change this to mount and save it. And this is actually deployed as a daemon set. So this NFS provisioner will run on every node in the cluster. And when we go now back to the cluster and to storage, we will see that this provisioner has registered itself as a storage class. And what that means is that we can go now to our project, and then we can either attach a volume while creating a workload, or we can also do the volume, create the volume atomically here, referring to the NFS provisioner, like the capacity, and then it will basically dynamically create a new volume that we can attach to the workload. Yeah, so it's already quite late, so let's just quickly go to the pipelines. So pipelines is really interesting if you want to have a very quick way to set up a CI pipeline with Rancher, and you don't already have one that like a Jenkins deployment outside, right? Or maybe you have teams that don't have access to a Jenkins, and they don't want to go in all the details of setting a Jenkins CI up. So this is a way to do that very quickly. The way it works actually is that we actually use Jenkins under the hood, but we make it very easy to create a pipeline here. So basically, you would select your repository, you would configure the build trigger, so like just a commit to the master branch, or even you could add triggers for new PRs, okay? And then you can define all the steps of the CI pipeline. So you can add another step here, run a script that runs your unit tests, and then add another step for integration tests or something like that. And then as a last step, you can do publish an image. So this is basically kind of like a source to image pipeline, where you, after passing through all the tests, it will create an image and tag it with for example, with the version name of the GitHub tag. And in one of the next versions, we will actually add another stage, which will give you a deployment step. so that you can build a full CI/CD pipeline in Rancher. Yeah, so I think we were pretty much done with the walkthrough. If there are some questions, Matthew, we can address them now.
Awesome. Excellent, Jan, very thorough. So there are a few questions. Let's see. Let's from Mikhail, I hope I'm not butchering your name. I think you actually covered this briefly, Jan, but he asked how to provide a correct SSL certificate to Rancher.
Yeah, so I think I'm just guessing, but I think he is referring to sorry, to the install, like to the certificate used by the Rancher UI and not in the cluster. So for the Rancher UI, like I said, by default we use a self-signed certificate, so that's why I get this warning here, right? But you can also either provide your own certificate. Basically, what you do is you have to have your certificate in PEM format, and let's see. And then when you start the container, you mount the certificate in it. Yeah. So there are steps here in our documentation. Basically, the Docker run command changes a little bit, and you basically provide the CA cert and any like intermediate certs and mount them in the container. So this is all documented here in the single node installation on the Rancher docs.
Awesome. Excellent. Okay, so the next one is from Milan. Thanks everybody, by the way, for being patient with the answers to some of these questions. So Milan asks, is there a way for Rancher to persist generated YML to some VC repository like Bitbucket?
Oh, it's probably with regards, I guess, with regards to the workloads. That's what I guess, at least. So you can export the YAML files. You can also download them. There is no direct integration like for shipping them off. So all the state is is stored in the etcd database. We don't use any additional like storage. But one thing that I might mention is this nice UI that you see. It's basically just another API client for the Rancher API. So this is all client-side stuff. And we actually make it very easy to find out how to query the API directly. So for any resource that you see in the UI, you have a context menu, which leads you to an API browser, like a REST API browser, and you can see how to interact with all these resources. So for example, I want to update this one. So it gives you even the curl command to do so. So if you want to implement something like that, some export for these YAML files, automated export, then you could certainly do that by talking to the API.
Awesome. Okay, going on. Christian asks, is there a capability or plans for deploying a workload across all managed clusters registered in Rancher?
Yeah, so this would be in the topic of federation, which is currently not supported in Rancher. And there's still some work being done upstream in Kubernetes itself to make it really production stable. So that would be a way to like to really support it as a first class function. Other than that, you can probably implement it quite easily yourself. I mean, if you just have a single application and want to deploy it across clusters, you can do it using the Rancher API or using kubectl commands. So, yeah. But they will be managed. Separately. Yeah, you don't get this kind of federation.
Okay. Okay, next one. Ewan asks, UN asks, I have a brand new Rancher 2.0 installed, but when I go to the catalog apps and click on launch, I don't see anything there.
Okay. Well, make sure that going to the global view and the catalogs that you have the library enabled. And yeah, the library. So this is just this is our own curated library. So as long as that is enabled, it should work. If not, that could be like a networking thing in your environment. So if that's not the case, please reach out on Slack, on the user Slack, and there's someone's going to help you.
Okay, cool. Next one, Donald asks, in Rancher 1.x, there is a catalog app for generating Let's Encrypt certificates that can be used with the load balancer. Is there any similar functionality in Rancher 2.0 to easily generate, renew, and use Let's Encrypt certificates with your applications?
Yeah, so the Let's Encrypt that is included in Rancher 1. I don't think we're gonna port that to 2.0 because there is already a pretty good service specifically for Kubernetes. It's called I don't have the name like on the top of my tongue right now, but if you do a search on GitHub for Kubernetes Let's Encrypt, it will show you that one. And I don't know if it's in the catalog. It might be in the catalog. So let's see if we enable this one. Yeah, I'm not sure. I don't think it's in the catalog. But as I said, so there's a pretty cool service for Kubernetes. Yeah, so I think it's the Kube Cert Manager. And basically, this should give you a YAML file here with the deployment. So as long as that's not in the catalog yet, you can just basically copy and paste this, and then or use kubectl or import YAML and create this and play around with that. So this one is pretty advanced. Okay.
Cool. Okay, last one that's been asked is from Ewan asks, is there any place to install proxy settings? He says maybe proxy settings. Any place to install maybe proxy settings?
Maybe, I don't know what meant by maybe, but probably referring to environments that are kind of locked down, where you don't have direct internet access. Then you need to launch, I think the agents, they will automatically detect proxy settings when they are in the environment variables on the node. But we have some documentation for air gap installations regarding proxies and stuff like that. So this is all you find this all on the Rancher 2.0 docs website.
Oh, yeah, he says he added an extra chat. He says was just asking about where to set up proxy settings inside Rancher.
Oh, okay. Yeah, so I think you have to provide it as an environment variable when you start the container. I haven't yet done it myself, so but please check in the documentation. If there's no answer for you, try Slack.
Cool. And then Fadi asks, we use Docker Compose. Is there a way to migrate all containers to Rancher?
Yeah, so I think he's talking about like migrating stacks to Rancher. So just to make clear that Rancher 2.0 is a new deployment. Okay, so there's no direct upgrade path from a Rancher 1 install to Rancher 2 install. Having said that, you basically need to migrate the workload configurations, which in the 1. In the case of using one dot with cattle would be Docker Compose files, and you need to create Kubernetes manifests from those Docker Compose files. But I think we are working on a tool to facilitate the migration from Docker Compose to Kubernetes manifest. Yeah, but I don't have any details yet on it. Again, this is a good topic for Slack to get some more people's attention.
Excellent. Okay, one more. Christian asks, is there any integration with Microsoft Windows Server DNS during or for node deployment? And he also says this is tightly linked to AD support, I guess.
To the DNS. So that's an interesting use case. I can't imagine right now how that is linked to the AD deployment. Yeah, maybe you can clarify the question of the DNS.
Okay.
Yeah.
Let's see if there's any other questions. I think that was all of them, actually. Oh, here he goes. He says, here's Rancher. Okay, Christian asked Rancher. So he's clarifying. He says Rancher to create DNS entries.
Oh, okay. Yeah. So I think we are working on adding those to the catalog. And basically all the integration. So in Rancher 1.0 we have all these integrations with external DNS where when you create a workload, it creates dynamically a DNS name or updates a DNS name. And I think the way this is gonna work is basically if you go to the load balancing. So one example would be that you specify the host name here, and then with that integration, it will update or create the DNS record on the external. But this is work in progress. Yep.
Okay. Cool. Okay, I think this will be the last question since we are near the end of our time. Mikhail asks, how do you limit a node to a specific workload?
Yeah, this would involve setting up like anti-affinity in the application. So if you go to node scheduling, so this is a way to set it up on the application side. I think there's the reverse way works as well, where you can configure it on the node side, but I've never done it. I don't know if there's support in the UI for it. So yeah, so this is basically something that you have to look up in the Kubernetes documentation. So I know how to do the affinity on the application side. I'm not sure right now if you can also like say, okay, this node only runs workloads with this and this label, for example. I would imagine that it's possible, but I can't tell you.
Okay. Cool. All right. Well, that was all the questions, sir. So thank you so much for doing most of the heavy lifting on this training.
Yeah, thanks everyone for joining.
Yep. Yeah, absolutely. If you don't mind, Jan, I'm going to let's see if I can just take back control of this presentation here and just give everybody the Slack user channel. So slack.rancher.io and our hashtag Kubernetes channel to ask more questions and explore. Other than that, thanks so much for joining. We will be posting this training, the recording, and the slides, and hopefully the Q&A too online, and send a link out to everyone in an email coming up. So have a great day, everybody, and a great end to your week. Thanks so much. Talk to y'all soon. Bye, Jan.
Yeah. Bye, everyone.